Good afternoon, and thanks for joining us for our virtual conference. And thank you to our sponsors for helping us put on this event. As a reminder, our Capture the Flag is going on during the entire event, with challenges ranging from easy for people who have never played before to complex for those who love to play. Stop over in the session area. The speaker for this half hour is Emily Gladstone Cole. She is back for her second year in a row at the Diana Initiative to talk about AWS security. There will be Q&A via chat on Hopin, and it will be either at the end of the talk, or if we have time, or in a discussion room after that. Take it away, Emily.
Awesome, thanks. So I am thrilled to be speaking at Diana Initiative again. I love this conference and all the amazing talks, although I'm not so in love with going right after Tanya Janka. I'm still absorbing some of those insights. But we'll push forward. A couple of quick bookkeeping notes. My slides will be uploaded to Shed after the talk, and I will also tweet out a link. So don't worry about getting screenshots if you miss one. Also, my Twitter handle is on almost every slide. Feel free to ask me questions or in the Hopin platform after the talk. So my name is Emily Gladstone Cole, and I'm your friendly neighborhood security engineer. Being a security engineer can be stressful, as you probably know. And sometimes I have nightmares about an issue with my company's security getting exploited and having those kinds of articles appearing to criticize us. So I start thinking about the ways we store data internally and any other secrets we might have, and the ways that people might gain access to them. It's not necessarily the best 3 a.m. thinking. So the idea for this talk crystallized when I attended a talk at B-Sides San Francisco back in February, which feels like 5 years ago, and heard about a nifty way to get AWS access keys abstracted off and handled by an SSO application. It made me think again about all the different ways things can go wrong with AWS access keys and the solutions that we personally have put in place to protect them. So, agenda, this introduction, 3 nightmares, and some best practices. So the obligatory bio slide. I came into security from the operations, DevOps SRE side, like Brianne Boland, in case you saw her talk. And after I spent some time on the operations side, I became a security incident responder instead of an operations incident responder after some training from the SANS Institute. And after doing a number of other security jobs, I landed about 2 years ago at Agari. We do email security, and I'm a security engineer there. Now, none of the cats you will see in any of these pictures are mine, though I do have 2 cats, and I sincerely hope that neither one will interrupt my presentation today. Obligatory disclaimers: I am not affiliated with Amazon or with AWS, and I'm not being paid to give this talk. I'm sharing what I've learned. The tools that I've found and that I'm presenting here are not the only ways to solve these particular problems. They're the ones that I've chosen for a number of reasons. Please do your own research. If you find any other tools that look really interesting, I would love to hear about it and get my toolbox to have a few more things in it. So let's start with the basic level set. What is an AWS access key? Access keys have 2 parts, the access key ID and the secret access key. Together, I'm probably just going to refer to them a bunch as access keys, and it's the pair, both parts. So the access key ID will always start with AKIA for a person. There are different things. It'll start with like ASIA for a role. And it's kind of like your username. Now, this is one, don't worry, you will see it in the logs. It's perfectly normal. The secret access key, on the other hand, really means secret. You get one chance to see it, and that's when you set up your access keys. And if you lose it, you need to make the key set inactive and generate a new one. Treat it like a password. Please don't put this key into your code. If you're like me and you've spent some time in an early stage startup, you know they don't often begin with a lot of attention to least privilege. So if someone gets a set of developer access keys, they can do a whole lot. anything that the developer can do. But least privilege is a completely separate discussion. So, okay, great. That's what an access key is. Let's talk about some nightmares. The first one, access keys in source code. Shudder. So Dome9, a cloud security company, checked some AWS access keys into a publicly available GitHub repository to see how long it would take for hackers to find them. They say they were accessed 3 minutes later. When the repo is public, that means the keys can be compromised in 3 minutes or less. Remember that if they get your keys, they can do anything that you can, up to and including view and copy your customer data or Bitcoin mining. There is a service out there, a site that tracks public commits of interesting information live. So this is a screenshot of some of the things that it found. Google OAuth keys and an API key in this example. It can spot your AWS access keys as well, and usernames and passwords and SSH keys and a lot of other kinds of things like that. Now, you can build a wall of shame for your office or go to a public website and watch those commits fly by to just remind you that people don't always think before they commit. So if you're like me and you don't actually like a wall of shame, what you can do to figure out that something is in your code is you can use a source code scanner. Now, Tanya talked a little bit about these. There are a bunch of different types out there. The 3 that I'm calling out right now are the ones that I've personally played around with: Trufflehog, Get Secrets, and Detect Secrets. And they can either look through the repository after the code has been checked in, which is Trufflehog and Get Secrets, or also Detect Secrets, or you can use them as a pre-commit hook, which Detect Secrets can do, so it'll warn you before you even check it in. And each one of them is slightly different. One may work better for you than another. Play around with them, give them a try. Now, okay, well, wait, what if you run this against one of your repos and you find something? What if you checked in some sensitive information? Don't panic. If you can, the best thing to do first is rotate the key. Now, sometimes you can't, and that happens, and it's not ideal, but there you have it. If you do panic and you commit over it with a version of the code without that sensitive information, then the sensitive information is still in your commit history. You just have to go back one commit and you'll see it there and in the diffs forever. The other way to handle it is to delete the commit that contains the access key and then do a new commit without that information. By default, Trufflehog searches your commit history as well as your current commit. So that's really useful if you want to look back and see how people's practices have changed, perhaps. But you do have to tell both Get Secrets and Detect Secrets to look back in the history. So, okay, maybe there have been some keys that were exposed. How do you know if somebody used them? You can watch your CloudTrail logs, but many services like S3 don't log read activity unless they're configured to. And you still have the problem of being able to pick out what is malicious activity and what's normal activity. This is where the idea of the honeypot or a honey token comes in. Honeypots are the lures that people set up to interest and trap hackers. It's data so intriguing that people will be drawn to investigate it. Things like HR database, 2020 bonus schedule. These are the same kind of things that people use as lures to get you to click in a phishing email. They're inherently compelling. Hey, let's find out about money. Side note, the first use of a honeypot technique that I know of is in Clifford Stoll's book, The Cuckoo's Egg, which is a very early computer security and forensics book. And it's a great read, especially if you're like me and you've spent a lot of time working on Unix systems. So, okay, how do you do a honeypot? How do you do a honey token? Let's say you store some kind of private data. You don't want to search the internet for that data because then you've exposed it to whatever tool you're using to search, right? That's bad. So use fake data. People came up with the idea of putting honey tokens into their databases or into documents so they could figure out when someone was accessing data they shouldn't because they were also accessing that fake data. Canary tokens are a free variant of that idea. They have a bunch of different formats And alerts can be generated when the token is accessed either to an email address or a webhook. And if your developers are like my developers, they'll kind of find this idea kind of fun. And it's a nice way to play around with some security concepts and get them thinking about who can access their data. So, nightmare number 2, old access keys. I took this screenshot from a production account at one point in AWS. I won't say if it's current job or past job, but this was production. And 1,626 days, that key on the bottom, 4.5 years old, but it was still being used that very day. And hey, now it's even older than that. Access keys don't automatically retire. If you think about it, 4.5 years is older than your standard tech refresh for a laptop. And most techs are going to jump on that brand new laptop as soon as they can. They're not going to want to stick with one that's 4.5 years old. So this key probably went from an old laptop to a new laptop. And think about your hard drive and laptop decommissioning processes. Do you clear those out properly? Do you wipe drives before you get rid of the laptops in whatever way? If not, maybe somebody just bought that access key on eBay and they're able to use it. That would suck. My philosophy is, hey, the longer an access key is around, the longer you have a chance for somebody to make a mistake and to have something happen to that key accidentally. So it's probably bad to keep them around for too long. So what's the solution? You rotate your access keys. If I know that any key that's on disk somewhere will stop working tomorrow, it's much less of a nightmare. Now, there are tools that will help you do this automatically if you want to. You can do it manually. This one tool, AWS Rotate IAM Keys, works for end user credentials, best for end user credentials that only need to be found in one place by rotating them every day. But that doesn't work for application users. Say you've got 2 web hosts and they each need to have access to the credentials. If you rotate on host A, then host B is out of luck once it's been rotated. Still, the thing that I like about using this tool is, once again, it's an intro to the developers to the practice of rotating keys. And once they start thinking about, oh, I should rotate my personal keys every day, then they're more open to the idea of, hey, I should rotate my application keys as well. So that leads me to my next nightmare, access keys on disk. It's related to the previous nightmare, of course. My previous 2 scenarios, the access keys are sitting there. Generally, they are on disk. Even if they do expire quickly, they're still sitting right there for the taking. So the 2 places where people are likely to lose laptops are bars and cars. At the moment, our laptops aren't spending a lot of time in either bars or cars, but the threat is still there. Disk encryption doesn't protect you from every attack. The File Vault 2 on the Mac, which I personally use, does a better job at protecting against specific attacks than version 1, and they're continuing to make improvements in that. So here are some other ways to expose keys on disk. You could drop them in environment variables. You can, if your developer has decided to be really, really verbose in their debug logging, they can write them to log files. Oops. Or, sorry, capital 1, they can accidentally expose them through the Amazon Metadata Service v1, along with a nice dose of server-side request forgery. In any case, those keys are there. They are accessible. How do you hide them? Well, there are vault tools that you can use to store your keys in a key store and interact with the pointers and not the actual keys. AWS Vault stores your keys in your Mac's keychain automatically, where HashiCorp's Vault will work for keys that are meant to be accessed from more than one place. I try to put in a recommendation. I don't recommend putting access keys for sharing into a password manager, because there is no proof when a secret gets accessed, which reduces accountability. You can no longer say, oh, I know exactly who has retrieved that information and who is using it. So the next step beyond having some kind of vault solution is don't use permanent access keys at all. This is the way that we've evolved our thinking. Security token service can generate temporary credentials, and those credentials, obviously, since they're temporary, inherently expire. And then you can use security token service within the context of roles, which can be set up and you assign policies to them. You can use cross-account roles, which will grant you access from one account into another account. And they can be used by instances or applications. So with that, let's jump over to some best practices. Quick reminder, I know it's a short talk, but I like to present things in multiple different formats. So if you were napping for the last 10, 15 minutes, here's a quick meme to catch you up. You should definitely rotate your access keys if you find them in your source code using a source code scanner. And not only should you rotate them sometimes, maybe you should rotate them automatically so that you don't have to remember, oh gosh, was I supposed to rotate my keys this week or next week? Just have it happen automatically. Better yet, use some kind of vault tool to store your keys encrypted, like AWS Vault or HashiCorp Vault. Or if you can convince your devs that this is the thing to do, use roles instead of keys or instead of usernames or passwords. It lets you use short-lived credentials and lowers your exposure risk. And as a follow-up, consider using canary tokens near your most sensitive data. So as I said, I like to say things in a couple of different ways to make sure they sink in with my developers. This started out as an internal tech talk, so I have some do's and don'ts here. Don't have permanently valid keys sitting around in your source code. Don't have any keys sitting in your source code. Don't let them sit on disk. Don't load them into environment variables. Do have keys that are valid only for a short amount of time. And have unique keys for each user and application, and only request a key when you're about to use it so that it's not sitting there accessible for anybody else. What are the next steps for us? We're looking at single sign-on with AWS. AWS has a single sign-on solution now. They have some integrations with Okta and other providers. But before that, here are some integrations that we were researching that are out there that are open source that people are working on to keep maintaining as well. It looks like an exciting next step, because then we can just trust our SSO provider, and we all have to trust our SSO providers, right? So with that, I have the references slide I put in there. Don't worry about it, it's going to be online. As I said, I'm going to tweet this out and put it in SCAD after the talk. And with that, I spoke faster than I expected to. I am all done with the material, and I would be happy to take questions.
Looks like we do have one question. Yeah, sorry, don't mind my
co-present.
Yes, from Mary Wang. She asked, what do you think about HSM? Is that very popular?
So HSM is a hardware security module. They are ways of doing key management. It's kind of a next stage of, or a slightly different stage of dealing with your key material. You can think of them as kind of loosely as as an alternative to Vault, although they are there are other uses beyond just the things that you put in Vault, which is purely a store. I know that if you're looking at managing customer master keys for data, that is definitely the way to go. That's kind of out of the scope of what I'm talking about here, which is really just those AWS access keys. In that context, I would probably say that they are overkill, but there are plenty of other contexts where you would want to look into them for sure. All right, do we have any other questions? Oh, hey, Allison, have I had issues with developers refusing to move to best practices and or overuse of permissions? Oh, absolutely. Yeah, definitely. There can be I've seen the philosophy plenty of times where a developer is just, I want to get this done, I want to get this out. You know, whether it's from they're building something in a Docker environment on their local machine and they don't worry about permissions, and then they push that container to prod, or in the dev account, I let my developers have pretty much admin privileges so they can play with new services or tweak things as they need to. And sometimes it's hard getting them to give those up as they're moving through the promotion process into our staging or our production accounts. It's a lot of separate stories. So how do you, quickly, how do you deal with that? I like to have a discussion of risks around those privileges. If you have a risk assessment, if you do threat modeling, that's a way that the developers can find out that it's really bad for the company to do things that way and get them bought in. All right, I see one last question there. Is there a good way of scanning leaks of corporate keys that are already out in public GitHub repos? So you can, the tools that I was mentioning for source code scanning, you can run them against a public repo, against a private repo. You just need to download it and run it, and there you go. You can, so yeah, you just need a copy of the repo and the scanner and go to town. Have fun or don't have fun, and I hope it doesn't spawn any nightmares for you. So if that's it, thank you so much, Diana Initiative, for inviting me to speak. Stick around, there's going to be lots of amazing talks, and thank you so much for your time and attention.